Right, ladies and gentlemen, we are going to be working with going to be going over the 7.3 notes. These notes should take an extreme short amount of time, mostly because this is actually mostly something that you have actually worked with in the past before, scientific notation. All right. It is essentially, as you see, it's going to be it's something that you've seen before. It's essentially just something that looks like this, something that looks like that, all right? It's a number written as a product of C and 10, basically, so just a number and 10, where C is just a number that's in between 1 and 10. Standard form is essentially just, regular numbers. So again, this is stuff you've seen before, all right? 5 times 10 to the negative 3, 2 times 10 to the negative 6 power, all right? I'm gonna pause. If you want to pause the video here real quick, you can, just to write this stuff down, but I'm going to continue on. So moving from scientific notation to standard form. So the way that you do that is we basically start with the decimal, all right? So we start with the decimal. And whatever this number is here, if it's positive, we move it to the right, and again, right is this way. And if it's negative, we move it to the left, that way. So I have this decimal here. I'm going to move it to the right 4 spaces. So one space would be this. Another space would be that. I'm going to actually rewrite it down here. So again, space here, then a space here. Now, we still move spaces even though we run out of numbers. So I moved 1, 2, 3, 4 spaces. And any of these remaining spaces that I have here, I just supplant with zeros, all right? So my final number would be 65,900 for that one. Now for this example here, still start with a decimal here, all right? Every time that we're moving forms, whether it's scientific to standard or standard to scientific, we always start with the decimal there, all right? And -6, so it's negative, so I'm going to move it left here, so this direction. I'm going to move it left 1. Actually, I'm going to rewrite it. I'm going to move it left 1, 2, 3, 4, 5, 6. All right. Now all these spaces here that I don't have a number, I'm going to put a 0 there. It's going to be 0, 0. So it's 1, 2, 3, 4, 5 zeros out front, then 4, 8, then 1. All right. So that's my number right there. All right, now, for standard form to scientific notation, all right, we're going to start still with the decimal. Now, if it's a big number like this, remember the decimal is always right at the end here. Decimal is always right at the end there. And then what I'm going to do is I'm going to move it over, and when I move that, I'm going to count. So I moved it over 1, 2, 3, 4, 5. Okay, now I'm heading to numbers, all right? Now, if I leave the decimal here, I'm left with the number 305. Remember, I want a number that's in between 1 and 10. 305 is not in between 1 and 10. If I move it over here, I get it to 30. I move the decimal here, 30.5. That is still not in between 1 and 10. So I want to move it now right to there, to 3.05. All right? So that's where I want to move it. It's usually in between the number, literally the first 2 numbers that you see, all right? So it's literally these 2 numbers right here. So when we write it out, 3.05 times 10. Again, all of our scientific notation, it's going to look like this. Some number, 3.05 times 10. And then however many spaces I counted, 1, 2, 3, 4, 5, 6, 7. That's going to go up here. That's my exponent there. All right? So that's my scientific notation form right there. Now for this one, start with the decimal place. Now, if I move this way, then now I have to move it this way because I still need to move it towards my numbers. I don't move it this way because, well, if I just keep moving it, I just keep adding 0, 0, 0, zeros, and I don't want that. So I'm going to take this decimal, move it here, move it here, move it here, and I'm going to stop right there because, again, if I stop the decimal there, it's going to get 9.046. And again, if I move it any more, it's a number that's greater than 10. If I stop short, it's a number that's less than 1. So I want it in between 1 and 10, all right? So what we're going to use here, 9.46 times 10, and then whatever we use here, 1, 2, 3, 4, all right? Now, if we're moving this way with our decimal, then it's going to be a negative number. So instead, it's going to be a negative 4, all right? Now, just always kind of think, and it's kind of wrote it up here, kind of hard to see, but essentially, if you have a bigger number, this exponent's going to be positive. And if you have a smaller number, like a really large decimal like this, then that number is going to be negative, all right? But essentially, that's what it's going to look like there, all right? So again, positive exponent and the negative exponent. Working some more out here. 3.0 times 10 to the negative fifth. We're going to take this decimal. We're going to move it. It's negative, so we're going to move it to the left. 1, 2, 3, 4, 5. All right. Spaces, going to put zeros. I'm left with 0, 0, 0.0003. All right, with a 0 out front there. All right. Example 6, 3.51. This is a positive exponent. If my exponent is positive, I'm going to move this way. All right, so 1, 2 spaces, and then I have to move 7 total. So 1, 2, 3, 4, 5, 6, 7. All right. So then I put zeros here, zeros, 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 and so it's 1, 2, 3, 4, 5 zeros at the end there. All right. So it's 35,100,000. All right. Now for this example 7 right here, I start with a decimal here. All right. Now I'm going from standard to scientific. So standard to sci. All right. Now I take my decimal here. I'm going to move it over. All right. We're going to move it this way towards the numbers. If I move it this way, I'm just going to add more zeros. I don't want to add more zeros. I want to move it towards the numbers, not away from the numbers. So I'm going to move it this way. 1, 2, 3, 4, 5, 6. Again, if I stop right there, I'm left with the number 1,000. I want a number that's in between 1 and 10. I'm going to move over. Even if I stop here, I have 10.62, but I don't even want the number 10. If I can even move the 10 to, I can even move it down further to 1. All right. So my number here, decimal's right there. This is my number right there, the 1.062 times, and then it's going to be times 10, always times 10. Multiply 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 to the 9th power. All right. So now example 8, sorry about that. So example 8 here, all right. I have my decimal, starting off with the decimal, and I'm going to move it towards the numbers, not away. 1, 2, 3, 4 spots. Stop in between the first two numbers you see, so 7 and 8. So it's going to be 7.81 times 10. I moved it this way, 1, 2, 3, 4 spaces, so it's going to be 10 to the negative 4th power. All right, so 7.81 times 10 to the negative 4. All right. All right. All right, so you guys should have seen that before. You guys should be honestly dynamos with that, all right? So you guys should be pretty good with that. Now let's try to let's try to work out with some of our rules of exponents that we've been using already, all right? So it's multiplication of two scientific notation numbers here. Again, sorry, I got something here. I'm going to use a blue one here. The multiplication of these. This is just this number times this number here, all right? So with example 9 here, 5 times 2.9. So literally what I'm going to do with my two numbers here, if I'm multiplying these together, I'm just going to multiply these numbers together. So 5, and then this is just times 2.9, all right? And then multiply to the 10. Now, with these 10s here, I'm going to start using some of my exponent rules. I have this, this is the same as 10 to the negative 8 times 10 to the 2. I have the same bases. All I do is just add those exponents. So it's 10 to the negative 8 times 10 to the 2. I'm going to add negative 8 and 2. That gets me negative 6. All right. Now, if you multiply 5.29 out, that's going to get you 14.5. And then still with the negative 6 out front there. Now, this is still a problem right here because, again, I want my number in scientific notation to be in between 1 and 10, all right, in between 1 and 10, okay? So what I'm going to do is I'm going to take this right here, I'm going to move it over 1 right there, all right? Now, if I do that, that gets me 1.45. Now, if I move it over, I have to add, and now it's really clear if I'm going to be clear on this. If I'm in scientific notation and I move my decimal to the left, I'm going to add 1. Now, if I moved it to the right, I'd actually subtract 1, all right? So again, if you move it left, it adds 1 to here. If I move it right, I'm going to subtract 1. I moved it left 1 spot there, so I'm going to add 1 to my -6. 1 plus -6 is just -5. That right there is my final number, all right? All right. Example 10, all right? I have this raised to an exponent. This, now think back to, like, say if we had a term like, 4xy to some exponent. Remember, we distributed, all right? Distributed to all the numbers, to all the bases, including the number. This is literally just the same thing, all right? Well, instead of having like an x, we have like, all numbers, but it's still the same process. Oh, sorry about that. We're going to take this exponent and distribute it to all of the exponents. Now 2.8 to the 1 power there, all right? Now remember, when I distribute, I'm multiplying these exponents. So 2.8 to the first, 1 times 6, that just turns into 2.8 to the 6th power, times 10 to the -2 times 6, that's just -12, so it's just going to turn into -12, all right? Because again, this -2 times 6 right there, because I'm multiplying those, all right? All right, so I'm going to calculator here real quick. If I multiply out 2 times 6, 2.8 to the 6th power, I get the number 481, all right? 0.9, just round to 1 there. Now again, this number here, number out front, clearly not in between 1 and 10. So what I have to do is I have to move the decimal place over 2 spots. Leaves me with 4.819 times. Now again, if I move it left, I'm adding. Now I moved it left 2 spots, so I have to add 2 spots here. So -12 plus 2 equals 10, -10. The new exponent down here is going to be 10 to the -10th power. So 4.819 times 10 to the -10th power. All right. Okay. Example 11 here. 4.5 times 10 to the 5th power over 1.5 times 10 to the -2nd power. All right. What I'm going to do here is I'm going to start off with these numbers here. I'm going to divide those numbers. All right. Now if it's a fraction, same as I did up here. I just multiplied if they're multiplying. This is a fraction, 4.5 over 1.5. I'm going to divide, all right? Just going to divide those 2 numbers out front there. And if you do that, you're going to be left with the number 3, all right? Now, with my exponents, let's go back to our exponent rules. X to the 7th over, let's say, x to the 4th. Similar bases, subtract the exponents. So I'm going to take 10 to the 5th minus a -2, all right? So I take the 5 and I minus a -2. Remember to minus the negative. Do not forget the negative. Minus a negative, that just turns into 2 plus signs. That gets me 7, all right? So when I add my final number, the number out front, 4.5 divided by 1.5, that was 3. And then when I divided my exponents, I just did 5 minus 2. Still with that 10 out there, 5 minus 2 got me 7, all right? That 3 is still in between 1 and 10, so that's a good number. That can stop right there, all right? Now, I don't have much time left, so I'm going to kind of breeze through this last one here. So this last one, what I would say is simplify the tops first, all right? Anything that has 2 numbers multiplying together, simplify those first. So again, what we're going to do, we're going to multiply 1.2 times 4.6. That gets us 5.5. 2. 10 to the 6 times 10 to the 2. I'm just going to add those exponents. That gets me 10 to the 8th. And then over 1.6 times 10 to the -3. These numbers out front here, I'm going to divide. So 5.52 divided by 1.6, that gets me 3.445. Times 10, and then the exponent, 8. Minus this one. So 8 minus a -3 gets me a +11. So it's going to be 10 to the 11th power. All right. So again, Simplify the multiplication first, then divide. That's all the time I have. Thank you.